Well, Assalamu alaikum, dear students. I'm Engineer Abdul Basit, and we are in week number 5, lecture number 9 of the subject hydraulics, which is basically the first lecture of this week. Okay, and after this, we will have the second lecture as well. Okay, the topic we are going to cover in this subject of hydraulics is fluid pressure and its measurements. Okay, so coming towards the fluid pressure, first of all, so let me remind you that in previous few lectures we have discussed about different terminologies of fluid mechanics, and then branches of fluid mechanics, you may say, and then different types of small definitions. Okay, and we have also discussed Newton's law of viscosity. So now we are continuing that previous discussion. Okay, so let me talk about that fluid pressure now. Okay, fluid pressure actually refers to that simple thing, that is force per unit area of fluid. Okay, for example, we are having this fluid in a container. So how much force this fluid is acting on a particular area, okay, a particular surface area. So if the area is like this base of this rectangle, so if this is the area, rectangular area, so whatever the force is acting on this area is actually pressure. Okay, so force per unit this area. um, in other words, you can say if we have a cube that is placed in water, which is present in a container. Okay, so on all sides of the cube there will be some pressure acted by the water on the on that area. Okay, you can say on that perpendicular area. Okay, so one concept is like all the pressures on this cube will be the same. Okay, but let me discuss it later on, okay, in detail. For now, you can say that that force that is acting on one side of the cube divided by the area of that side is actually called pressure. Okay, so here is the definition. We see that whenever a liquid such as water and oil is contained in a vessel, so this may be due to water, that pressure may be due to water, due to oil, any other type of liquids as well. It exerts some force on all points on the sides of the bottom of the container, sides and bottoms, all of that. So that force per unit area is called pressure. Okay, and that force is actually represented by that capital P, and small a is actually the notation for area. Okay, and this is that pressure. Okay, so let me move it further. Here it is. Let's say another concept to describe, or another way to describe the fluid pressure is pressure head. Okay, and that pressure head is actually this H. Okay, in simple words, what does it mean by this H, and why it is called as pressure head, and why it is an alternative to that pressure description? So here it is. For example, we are having some water in this container. That water will exert some pressure on the bottom of the container. Okay, so whenever we are increasing this head of water, which is simply the level of water or the height of water that is present in the container. Okay, whenever we are increasing this height of water, so the pressure on the bottom of this container will increase. Okay, and whenever we are decreasing this H, or this water level, okay, downward, so this will be like the pressure on the bottom of the container will decrease. So ultimately you can say this head is actually the representation to that pressure on this bottom. Okay, when this is increasing, pressure is increasing. When this is decreasing, pressure is decreasing. So you can say that this is an alternative to that pressure. Okay, in other words, we can say that this pressure is actually equal to that weight of the liquid in the cylinder, that weight of the liquid over some specific area. Okay, so for example, we are having this container, this whole container. Okay, so the pressure due to this container will be like the force exerted by this liquid. Okay, so how we can calculate that? Unit weight of this liquid multiplied by H multiplied by area. Okay, so H and area is actually the volume, and unit weight multiplied by volume will be equal to the total weight. So the total weight is actually the pressure head, or you can say the pressure okay, and here this H is actually the pressure head, okay. Dividing by area, so whenever you divide something by area or volume, so it will be converted to intensity, so then it will be pressure intensity on that particular area. So you can say pressure can now be described in the form of unit weight into head of water, or pressure head into area divided by area on which it is exerting. Okay, so area will get cancelled with area, so you can say that pressure is equal to unit weight into H, and this unit weight is actually the unit weight of this fluid, whether it is liquid, this is oil or water or petrol, whatever that is. Okay, and the rest of the things are explained over here as well. So in simple words, if we look at this definition, force per unit area, so the unit of force is actually newtons and area is meters square. So you can say in simple words that the unit of pressure will be newtons per meter square, okay, and kilonewton per meter square. Okay, so we can magnify this unit as well. As a height of equivalent liquid column, as a height of equivalent liquid columns actually refers to that it is head H, okay, this thing. So two types of units can be used, okay, newton per meter square, that is that complete force per unit area definition, and this is that head, okay, H. So you can say that pressure can also be represented in the form of meters, in the form of feet, and so on. Okay, the pressure is always expressed in pascals, okay. So why it is expressed in pascal, and what pascal is equal to, the 1 pascal is equal to 1 newton per meter square. So this is their simple thing, okay. 1 pascal is equal to 1 newton per meter square, okay, and 1 kilopascal is equal to 1 kilonewton per meter square. 1 megapascal is equal to 1 mega newton per meter square, okay, and so on. Okay, so this is that simple thing. Whenever a unit of pascal is given, so you will be able to convert that unit into any of these units that are given over here. Okay, uh, let me utilize that formula to solve a simple problem. Find the pressure at a point 4 meter below. 4 meter below refers to this 4 meter is actually H, okay, below the free surface of water. So free surface of water is the top surface of the water. Like for example, in this container, the surface of water is this one. Okay, let me draw it with the help of a pen. This is the surface of water. Okay, so any head or height till this one is H. Okay, so similarly you can say this is that formula uh, for pressure determination from head. Okay, so head is given, that is 4 meter. Okay, so put it over here, and unit weight of water, we all know that this is 9.81. okay, so by multiplying these two things you will get this, which is actually the pressure in kilonewton per meter square. So you can convert it to the kilopascals as well. That will be the same thing, okay, because kilonewton per meter square and kilopascal are the same units. Okay, now coming towards the second example, a steel plate is immersed in an oil of specific gravity, a specific weight, here it is specific weight, 7.5 kilonewton per meter cube. So you can say this is their specific weight, which is actually that gamma, okay, that gamma, okay, up to a depth of 2.5 meters. So this is actually that H given to you. What is the intensity of pressure on the plate due to the oil? Okay, so this oil is having unit weight, this thing. Okay, so if unit weight is given, so you don't need to convert it to any other type of units. Okay, so this is unit weight in kilonewton per meter square, and H is given. The equation for pressure determination is W into H. Okay, so H is also given and unit weight is given. Multiply both of them, okay, and this will be the answer, and in kilopascal this will be the answer. So it is quite simple. Here it is, example 2.3. okay, calculate the height of a water column. So this is now something like an other type of a definition it is, okay, like confusing you with the formula. Okay, here it is, calculate the height of a water column equivalent to a pressure of 0.15 megapascal. So this is that pressure given to you, okay, and you are required to find out the height of water. Okay, you need to find out the height of water. Okay, that is a height of water column in meters. Okay, so how we will do it? Simple. P is equal to W, or unit weight, into H. This is that formula. So H will be equal to P, okay, divided by divided by unit weight. So if unit weight is given to you, where it is water, so it is water. Okay, so the unit weight of water is 9.81. This is constant. Okay, so already given to us. And pressure is equal to 0.15 megapascal. So you have to convert it to kilonewtons per meter square, so it is converted. Okay, and from here you can determine that H for yourself. Okay, H will be equal to this thing. So this is that height of water which will create how much pressure? This much pressure. Okay, 0.15 megapascal. Now coming to this fourth example, what is the height of an oil column of specific gravity 0.9 equivalent to a gauge pressure of 20.3 kilopascal. Okay, so a gauge pressure is also given, that is simply P, or the pressure, 20.3, and specific gravity of a column of an oil is also given. Okay, and you need to find out the height. So H is need to be determined, and from this specific gravity we will determine the unit weight of oil. Okay, gamma oil, we determine this thing, and then this is pressure given to you. Okay, so pressure in unit weight is given, you will determine H. Okay, so H, here it is, the unit weight determined from the specific gravity. Okay, and this is again that head. Okay, so here it is, that simple equation for head determination, is you are having that pressure and unit weight, both of them. Unit weight is determined from here and pressure is given here, 20.3. Okay, so all these things are quite simple, and we have done it repeatedly, so no need to do it in details. Coming towards atmospheric pressure. Okay, so let me simply describe it from here. Okay, what does it mean by atmospheric pressure? For example, we are having air around us. Okay, and that air is consisting of small molecules, and those small molecules are do have some weight. Okay, like these are the small molecules. Okay, and these molecules will have some weight as well. Okay, and due to that weight, it will tends to come down, and due to gravity it will tends to come down. Okay, and it will be converged at some area near to the surface of ground. Okay, and that will exert some pressure on the surface of ground, or the ground level. Okay, so that pressure that is acted upon by the air molecules on the surface of ground is actually called as atmospheric pressure. Or you can say the pressure of these air molecules, the molecules or the particles present in air, is actually called atmospheric pressure. Now in correct words, you can say that the pressure of an air column refers to, for example, we are having a known width of area. Okay, a known width, or a known cross-sectional area. Okay, so that is to make that definition a bit specific. Okay, so the weight of the particles of air are an air column acting on the surface of water, on the surface of seawater or sea level, is actually called atmospheric pressure. So here we have specified two things. Number one, an air column. So we are not talking about the indefinite area of air that is acting upon the surface of water. Okay, and we have specified a level of on which that air is acting as well. Okay, so what does it mean by level? As you know that the sea level is actually the water level of the sea, okay, that is constant throughout the world. Okay, so you can say that uniform level is actually chosen to select that pressure on a uniform surface. If we are considering, for example, the ground surface, so a ground surface is not uniform. Somewhere there are ridges, somewhere there are valleys and different types of ups and down, crest and trough. So that type of situation may not clarify that type of that pressure for us, okay, atmospheric pressure for us. So at each elevation that will be different. So that's why we are selecting the sea level to measure that pressure of air on the sea. Okay, so you can say the air column will exert some pressure on the sea level, that is called atmospheric pressure in very simple words. Okay, so that atmospheric pressure are two types of atmospheric pressure. One is local atmospheric pressure and the other one is constant atmospheric pressure. So constant atmospheric pressure is actually that atmospheric pressure which is which is determined on the surface of sea level. Okay, and the other one we are having is the local atmospheric pressure, which is determined at any elevation from the sea level. Okay, that is called, for example, here it is the Mount Everest, for example. So on Mount Everest you can see that the pressure is 31 kPa, kilopascals. Okay, and above that Mount Everest some at, you can say, at that space region, so it is at 0 kilopascal, no pressure is there. And at the water level the pressure is increased, that is 101 kilopascal. So you can say the local pressure at sea level is 101, the local pressure at Mount Everest is 31, and the local pressure at atmospheric pressure at in space is actually 0 kilopascal. Okay, so I think that is quite clear to you how we will take that air column. So you can say here this is that sea level, okay, on the globe, and we have selected a unit area for us, 1 meter square. Okay, so how much of the air column will create this much kPa of pressure is actually that head of the air column that will produce the atmospheric pressure. So that will be one atom. Okay, so in simple words you can say this is that area, okay, on which we have selected that column, air column, okay, for x height. So if it is atmospheric pressure due to air, so it will be the height required will be here it is 103 kilopascal. Kilopascal is actually, or kilonewton per meter square is actually the pressure due to that air. Okay, if that column is made up of water, okay, so equivalent to that air it will be 10.3 meters. So this height will required to be 10.3 meters. Okay, 10.3 meters for water. Okay, and this height for air will be from the sea level to the space. Okay, so you can say to the last, to the end, okay, it will be that height for air. Okay, I'm talking again and again for air. Okay, and if this column is made up of water, so then it will be 10.3 meters for water. Okay, this is for water. And same more similar way you can say that if this that column is made up of mercury, then the height required to produce this much pressure is 103 kilonewton, 7.760 millimeters of mercury height or head is required. Okay, so you can say head of mercury, in head of mercury we can say that the atmospheric pressure is equal to 760, and head of water it is 10.3, and in head of air it is like the height from the sea level to the space. Okay, and if you are counting it in the form of pressure, so it will be 103 for all cases. Now let's talk about gauge pressure and absolute pressure. So let me straight away move to this diagram. Okay, already I have told you that atmospheric pressure is having some uh, some unit or some amount. So in kilopascal or kilonewton per meter square, it is 103. Okay, 103. Okay, that is in kilonewtons per meter square. Okay, and in psi it is a pounds per square inch. Okay, so this will be 14.7, or 1 atoms is in unit of atoms. Okay, so if this line, this middle line, this line is showing us the level of atmospheric pressure, or that atmospheric pressure. So whenever we are measuring a pressure relative to this atmospheric pressure is called gauge pressure. Okay, for example, you can say that the pressure, zero pressure is taken at atmospheric pressure. Okay, whenever we are measuring pressure from zero, okay, from 0 psi, okay, to any point, this will be called absolute pressure. So you can say absolute pressure is measured relative to the absolute zero, and gauge pressure is measured relative to atmospheric pressure. Okay, so in other words, you can say whenever pressure is less than that of that gauge pressure, for example, this gauge pressure is less than that of the atmospheric pressure, so it will be called a negative atmospheric pressure, negative gauge pressure. This will be called negative gauge pressure, or in other words, you can say this is vacuum. Okay, if that gauge pressure is greater than that of atmospheric pressure, so that will be called positive gauge pressure. Okay, that will be positive gauge pressure. Okay, or that may be called as compound pressure or someone. If compound pressure refers to if a pressure is measured relative to other than absolute zero and atmospheric pressure, other than absolute zero and atmospheric pressure, that will be called compound pressure. But that other datum should be in between zero and atmospheric pressure, should not be greater than atmospheric pressure, you can say. Okay, if some pressure is measured relative to some point or some datum line other than atmospheric pressure and that of absolute zero, but it is greater than atmospheric pressure. Okay, so the datum line is placed at a point above atmospheric pressure. Okay, that is called this differential pressure. So we have discussed in total the 6 types of pressures. You can say 7 types of pressure. Number 1, we have atmospheric pressure, so we have discussed it in detail. Then we have gauge pressure. Gauge pressure is actually that pressure which is measured relative to atmospheric pressure. Okay, so this line is actually showing us atmospheric pressure. And then we have discussed about the absolute pressure, which is actually the pressure that is measured relative to absolute zero. At this point, this is absolute zero. Okay, and then we have discussed vacuum or negative pressure, which is a gauge pressure, type of a gauge pressure which is having value below atmospheric pressure. So again, it is measured relative to atmospheric pressure, but as this is below atmospheric pressure, okay, so then it is called that of vacuum pressure or negative pressure. Again, a gauge pressure which is measured relative to atmospheric pressure is having a value greater than atmospheric pressure, that is called positive gauge pressure. Now then we have compound pressure. So compound pressure is actually refers to that type of pressure which is measured relative to a reference line or a datum line which is in between zero and atmospheric pressure, or you can say other than atmospheric and zero pressure but less than atmospheric pressure. So that will be compound pressure. Here it is. Then we were talking about differential pressure. So that is the pressure that is measured relative to a datum line which is other than atmospheric pressure and that zero or absolute pressure, absolute zero. Okay, but it is greater than atmospheric pressure. Then it is called differential pressure. Okay, so you can say that compound pressure and differential pressure are having a difference of the datum surface, this datum surface is below atmospheric pressure and this one is above atmospheric pressure, but this shouldn't be equal to absolute zero. This shouldn't be equal to atmospheric pressure. Okay, and in gauge pressure and absolute pressure, the difference is this is measured relative to absolute that atmospheric pressure, and absolute pressure is measured relative to absolute zero. So this is that whole story which is written over here. Okay, you can go through it as well. This is some simple example of gauge pressure. Okay, gauge pressure, this gauge is actually giving us a pressure of 0 bars. Okay, whenever you are going to, for example, someone who is checking that air in your car tires. Okay, he will do, first of all he will pick up a gauge, and when you see that gauge, you'll find out that the pressure in the gauge measured initially whenever it is not attached to your tire, it is 0. Okay, so you can say absolute pressure or absolute zero, or the starting point of this gauge is actually taken as 0, while some atmospheric pressure is acting on it. Okay, this shouldn't be equal to 0. There is some atmospheric pressure on it. Okay, why it is considered 0? Because it has taken that atmospheric pressure, it has its reference point, and starting from it is 0. Okay, and then they are counting that pressure above atmospheric pressure. So this gauge is actually that device for gauge pressure. Okay, this is there another picture of that same thing. Okay, so in next lecture of this same week, we will discuss about that piezometer and manometer. Okay, thank you very much.